Yeah, by what shortcut? Angle, angle, right? If two triangles have the 32 degrees and they're both right, they'd be similar by angle, angle. So all their sides are going to be in proportion. So really, the only thing new we're learning is the names of those ratios. So we learned that if you write the opposite over the hypotenuse of a triangle, so like if this were the angle we were talking about, the opposite would be A and the hypotenuse would be C. So opposite over hypotenuse, we call that ratio sine. Adjacent over a hypotenuse, we call that cosine. Opposite over adjacent, we call that tangent. So the ratios are just like any other triangle ratios. It's just that they have called them sine, cosine, tangent. Yes. Am I not recording? I think I am. Yeah, I am. It just, for some reason, keeps disappearing, but it's there. Okay? So let's just quickly review one of these. So if we call that theta, what is the sine of theta? Laura, first of all, what's the ratio? Sine is SOHCAHTOA. So, oh, no, that'd be OA. Hypotenuse. Opposite over hypotenuse. Hey guys, we're having a quiz tomorrow over, not over this, so you have another day to memorize that, but we are having a quiz tomorrow over Pythagorean theorem and special right triangles like 30, 60, 90, and 45, 45, 90. Just a very short quiz, and then we're going to keep going. Like it's two or three questions. Very short, but you need to memorize. That made me think of it when memorizing. You need to memorize that 45, 45, 90, and 30, 60, 90 triangle, okay? Okay, just like you got to memorize these. SOHCAHTOA. So is SOHCAHTOA, right? All right, so if it's opposite over hypotenuse, what's opposite of this angle? 7, and what's the hypotenuse? 10. Good. All right, what's the cosine? Bryn? First of all, what's the ratio of cosine? No, that's tangent. Ka. S-O-H. It's S-O-H-C-A-H. So A stands for right. Adjacent over hypotenuse. So in this case, the adjacent would be 5, and the hypotenuse? 10. Good. And tangent, Ria? First of all, what's the ratio? Good. And the tangent would be? Right. Good. Okay. We all remembering this? Yes. No, you can just leave them like that. Yeah. Okay, so hypotenuse. Okay, so we know, and this is a good strategy. Label them before you come up with all these ratios. Label the sides. So you absolutely know which one is hypotenuse, right? Which one is that? 10. No matter what angle we pick, that's going to be the hypotenuse. Now the adjacent and the opposite are going to be dependent on which angle I mark here. So if we're talking about this angle, the opposite side is going to be the side that doesn't touch the angle. So that's going to be which one? 5 or 7? 7. So that's going to be the opposite. Okay? And the adjacent, because the opposite and adjacent are the legs. They have to be the legs, not the hypotenuse. So which leg is touching the theta? The 5, right? So if I label them A, O, and H, it makes it easier to fill them out. Okay? So let's say this one is alpha. Find the sine, cosine, and tangent of angle alpha for angle B, for triangle B. Okay, because right triangles are so useful. Whenever I see one on a test, I get excited because there's so many different things you can do with a right triangle. We've learned how to find sides based on the geometric mean. We've learned Pythagorean theorem. We've learned trig ratios. We've learned special right triangles. Like there's so many options with right triangles. They're our best friends in geometry. All right, so let's learn one more thing we can do with a right triangle, and that is find missing sides based on trig. So first of all, would I be able to find the missing sides using Pythagorean theorem? How come? Yeah, I only have one side, and you need at least 2 out of 3 to find the other missing side, right, in a Pythagorean theorem? Otherwise, you'd have 2 variables. So whenever I see that I've got an angle and one side, I know that sets off in my head trig. I should use sine, cosine, or tangent. All right, so let's say I'm trying to find this side. All right, so I'm going to find the side, and I'm given this side. So from the 63-degree angle, is this opposite, adjacent, or hypotenuse? Opposite, and this is hypotenuse. Which trig function relates opposite and hypotenuse? Sine, right. So the sine of a 63-degree angle is equal to opposite, which is x, over hypotenuse, which is 12.9. Okay? Now, it looks kind of like I have 2 variables, but sine of 63 is a number. Type in your calculator. What's sine of 63? 0.8910. Right? So now I can write that 0.8910 equals x over 12.9. And that's an equation. It's not pretty, but it's an equation I can solve, right? So what would I do to solve for x here? Yeah, multiply both sides by 12.9. Okay, those 12.9s would cancel. Leave me x on this side. And then 0.8910 times 12.9 is 11.494, so 11.49. Let's round. Unless the directions on a worksheet or a test tell you otherwise, let's round the answers to hundredths and the signs and the trig functions to 10,000. Okay? So this one is 11.49. All right? See if you can do the same process and find that side. Yeah. Okay. We've already seen a couple people. A good, just quick second check is this is the hypotenuse, right? So it should be the largest side. So if you find either of these two sides to be more than 12.9, that should tell you, oh, I must have made a mistake. I typed something wrong. Okay? So it doesn't tell you what the right answer is, but it'll tell you if you accidentally made a quick data entry error or something. All right, so there's a couple ways we can do this. We could use tangent, we could use sine, we could use cosine. What did you guys use? Cosine, okay? Yeah, I tend to like that, using cosine instead of tangent, because it doesn't involve this side, which is rounded. So it's just more accurate. All right? Yeah, that's why, because this is rounded. So, yeah. As long as, like, I usually, like on tests, I'll do both ways just to see what I get, you know. As long as you round it 4 and 2, and same as I always do, then I'll know what that was from. Because this side would be adjacent and then hypotenuse. And a cosine is adjacent over hypotenuse. So cosine of 63 would be y over 12.9. Okay, then I type cosine of 63 in my calculator. What do you get? 4,540 equals y over 12.9. Multiply both sides by 12.9, and I get y is equal to, somebody? 5.86? Is that rounded correctly? Is it, what was it, 5.86 something? 5.86 what? 5.856, so it's 5.86. Okay? All right, then the only other kind of tricky thing you have to watch for, let's say I'm solving for this hypotenuse. Okay, we know this is h. So if this is 39, what's this one? Opposite or adjacent? Opposite. And this one would be adjacent. Okay, so if I'm looking for this one and I have this one, what trig function combines adjacent and hypotenuse? Cosine. So I do cosine of 39 equals opposite or adjacent over hypotenuse. Okay? Now this is a little different because the variable is in the bottom of the fraction, and you can never solve a variable when it's in the bottom of a fraction. So how do we get it out of the bottom? Right, you multiply both sides by h. Okay, so that cancels that. And then I have the h moved over to this side. So I have h times, and what's the cosine of 39? 7771 equals 20, because the h's have canceled. Okay, now how do I get its h times 0.7771? So how do I get h by itself? Divide, right? Divide by point, where am I? Okay, why won't this go down? Divide by 0.7771. I'm sorry, why would I what? All right, so since I'm trying to get h by itself, and this is multiplying, I know the opposite of multiplying is dividing, so I'm going to divide both sides by 0.7771. Okay, so those cancel, and I have h left on this side, and what is 20 divided by 0.7771? 25.74. I can't solve for the hypotenuse when it's on the bottom of a fraction, so I have to get it out of the bottom of the fraction. And the way you do that is I multiply both sides by h, so now this, the one that was in the bottom of the fraction goes away, right? They cancel each other out. And now I have an h in the top of the fraction, or in the top. Yeah. Okay? So this one would be 25.74. Okay? All right, and I think I want to stop there and give you a chance to practice this.